हेलो एवरीवन, वेलकम टू आवर चैनल EEniverse इलेक्ट्रिकल इंजीनियर्स यूनिवर्स में आप लोगों का स्वागत है। सो टुडे आई एम गोइंग टू डिस्कस ऑन बेसिक इलेक्ट्रिकल फर्स्ट चैप्टर बेसिक कॉन्सेप्ट लेक्चर नंबर 1. सो इन दिस लेक्चर आई एम गोइंग टू डिस्कस ऑन नेचर ऑफ इलेक्ट्रिसिटी, यूनिट ऑफ चार्ज, फ्री electrons, electric current, measurement of current. So let's start. Nature of electricity. According to the modern electron theory, the matter is made of very small particles called molecules. So, according to the modern electron theory, matter is made up of very small particles that is called molecules. And a molecule is made up of atoms. And molecules is made up of atoms. The central part of the atom is called nucleus. So in this diagram you can see this is the nucleus. This is a atom. This is the structure of atom. So in this atom, the central part, that is called nucleus, and in the nucleus there have two elements, protons and neutrons. The nucleus contains proton and neutron. Proton carry positive charge and neutron there have no charge present. So in the nucleus, these are the protons, and these are the neutron. Proton carry positive charge and neutron they have no charge present. Okay. Then electrons that is negatively charged. So the electron is moved around the nucleus. So surrounded the nucleus, electrons are moved in different orbits and the electron is negatively charged. So that is revolve around the nucleus in the different orbits. So some important notes that is we need to must be remembered, that is an atom is electrically neutral when the number of protons and number of electrons are equal. So when the number of protons and number of electrons are equal in a atom, then this atom is electrically neutral. And the mass of proton is 1837 times of electrons. So now I'm going to see charge in a body, how to depends on protons and electrons. So if in a body the protons and electrons number are equal, then this body is neutral. So in this body there have no charge is present. If defect of electron, then if in a body if electron is defect or less than the protons number, then this body is positively charged. So if in a body the protons number is more than electron, then this body is positively charged and the net charge will be positive. And if in a body the electron is excess or if in a body the number of proton is less than the number of electrons, then this body is negatively charged, or net charge equals to negative. So note, the charge on the body depends on the relative number of electrons and protons. So the unit of charge, uh, the unit of charge. So the charge on an electron is very small. The charge on an electron is very small. It is not convenient to use electron as the unit of charge. So the charge on an electron is very small. So it's not convenient to use electron as the unit of charge. So coulomb, that is denoted by C, is used as the unit of charge. So coulomb is used as the unit of charge, and 1 coulomb equals to charge on 6.25 into 10 to the power 18 electrons. So 1 coulomb equals to 6.25 into 10 to the power 18 electrons. One remembering point. So a body has a positive charge of 1 coulomb. That means a body has a positive charge of 1 coulomb. That means it indicates if it has a defect of 6.25 into 10 to the power 18 electrons. So when a body is charged of 1 coulomb, then this body defect of 6.25 into 10 to the power 18 electrons. Okay. So now I am going to discuss on free electrons. What is free electrons? So before going to discuss free electrons, first we learn this atom structure. So this is a structure of atoms. So the center part of the atom is called nucleus. So in the nucleus there have two elements, neutron and proton. Proton is positively charged, neutron is negative. Neutron have no charge. This is a neutral part of the atom, and electron is negatively charged. So in the atom, the center part of the atom is called nucleus. Nucleus contains proton and neutron. Neutron have no charge. Neutron has no charge, and proton is positively charged, and electron is negatively charged. It moves around the nucleus. So in the last orbit, these electrons are called valence electrons. So in the last orbit, electrons are called valence electrons. So in the last orbit, that electrons are exist. These electrons are called valence electrons. In the metal, these electrons are very these electrons are attached. These electrons are attached very loosely. So in case of metal, these valence electrons are attached with nucleus is very loosely. So it can very easily remove or detached from the nucleus or atom. Okay. So this electron called free electrons. So the last orbit in a atom, the last orbit in an atom, the electrons are exist. Okay. So the electron exists in a last orbit of an atom is called valence electrons. And in case of in a metal, these valence electrons are very loosely attached with the nucleus. So these electrons can very easily remove or detached from the nucleus. So these electrons are called free electrons. So now in certain substances, especially in metals, the outermost or valence electrons are loosely attached to the nucleus. These electrons can be easily removed. They are called free electrons. So this is the structure. These are the free electrons. These are free electrons. And these are the metal atom. Okay. So what is electric current? Electric current is the flow of free electrons or charge in a definite direction is called electric current. So the flow of free electrons or charge in a definite direction is called electric current. So you can see this is a copper strip. This is a copper strip. In the copper strip, they have a lot of free electrons. So when we are connecting a battery or a potential source, then the electrons flow from negative to positive terminal, and the conventional current that is flow from opposite to the flow of electrons. Okay. So when a source of electric potential like battery is connected, then free electrons in the conductor move from negative to positive terminal. So when in a metal or conductor, when we are connect a EMF source or voltage source or potential source, whatever, like a battery, so then the electrons flow from negative to positive terminal, and the current that is flow opposite direction of electron flow. That means in this diagram, electrons are flow in this direction, and conventional current that is flow this direction. So the flow of electrons is opposite to the conventional current, or the conventional current direction is opposite to the electric flow of charge. Now the conventional versus electron flow. So the electron flow, that is actually flow that is negative terminal to positive, and the conventional current that is assumed direction that is flow from positive direction to negative direction. Okay, so positive terminal to negative terminal, the conventional current is flow. So note, conventional current flow from positive to negative and opposite to the flow of electrons. So now the measurement of the current. So electric current is the rate of flow of charge through the cross section of conductor. So what is electric current? Electric current is the rate of flow of charge through the cross section of the conductor. Then average current. What is average current? Average current I equals to Q by T, where Q is a charge in coulomb and T is a time in second. And instantaneous current, what is instantaneous current? I equals to dq by dt, where dq is the small change in time dt. Sorry, the unit of current is ampere, and 1 ampere equals to 1 coulomb of charge flow in 1 seconds. So the current flow due to electrons, the current flow due to electrons. So you can see here metal strip is here. In this metal strip there are a lot of electrons, like we consider n number of electrons are present in the mm, electron strip, and this n number of electron is passed in the time t seconds. So if n number of electrons pass through a cross section in time t seconds, then the charge passed q is equals to n into e. Therefore, I equals to q by t equals to ne by t, where e equals to minus 1.6 into 10 to the power minus 19 coulomb. So note, more electron passing per second, then the current also more. So the summary of the lecture number 1, that is, matter is made up of atom with protons, electrons and neutrons. Charge depends on the relative number of electrons and protons. Free electrons in the metals are responsible for the conduction. Electric current is the flow of charge in definite direction. Unit of charge equals to coulomb. 1 ampere is equals to 1 coulomb per seconds. Direction of current is opposite to the electrons flow, and more free electrons, better conduction in metal. So that's all. Thank you.